Now, in this lecture, we will find out the radius of the biggest circle. In the drawing, we have 4 circles. Those 3 circles are inside the biggest circle, and the radius of this circle is equal to 4 units. The radius of this circle is equal to 9 units, and the radius of the smallest circle is equal to 1 unit, and we want to find out the radius of this biggest circle, the 4th circle. Okay, so first of all, I will explain you 2 theorems. The theorem of external point, external lunge. What is external lunge? Actually, 2 circles can be tangent to each other in 2 different ways. The first way is external lunge. Those 2 circles are tangent to each other at point S. Point S is the point of tangency, or point S is the point where the 2 circles are touching each other, and suppose that this circle, the center of this circle is at point M, and the center of this circle is at point O, and the radius of this circle is equal to capital R, and the radius of this circle is equal to small r. Then the distance between the centers of those 2 circles is equal to r, capital R, plus small r. Why? Because OS is the radius of the big circle. Why? Because it starts from the center of the circle, that is to say from point O, and ends at point S, that is a point on the circle itself. And this is the definition of the radius. That is to say, OS is the radius of this circle, that is to say it equals to capital R, and line segment SM or MS starts from the center of this circle, that is to say from point M, and ends at point S, that is a point on this circle itself. Therefore MS is the radius of this small circle, that is to say it equals to small r. Therefore OM equals to OS plus SM, that is to say OM equals to R, capital R, plus small r. So in conclusion, we can say that when there is an external lunge between 2 circles, that is to say when they are touching each other at an external point, then the distance between their centers will be equal to the sum of the lengths of their radiuses. In this case, it will be equal to capital R plus small r. And so this is the one type of tangency between 2 circles, and there is also another type of tangency between 2 circles. The second type of tangency between 2 circles is when they are touching each other internally. This point S is the point of tangency between the big circle and the small circle. They touch each other at point S, and so this is the definition of internal lunge. when two circles touch each other internally or are tangent to each other internally, then this is defined as internal length, and the distance between their centers, that is to say OM. Here OM, as you can see from the drawing, OM equals to SO minus SM. Again, OM equals to SO minus SM. But what is SO? SO is the radius of the big circle. Why? Because it starts from the center of the circle, that is to say from point O, and ends at point S, that is a point on this circle itself. Therefore, SO is the radius of the big circle, that is to say it equals to capital R. And here SM is the radius of the small circle. Why? Because it starts from the center of the small circle, that is to say from point M, and ends at point S, that is a point on the small circle itself. Therefore, SM is the radius of the small circle, that is to say it equals to small r. So in conclusion, MO, the distance between the centers of those two circles, equals to the SO, that is the radius of the big circle, that is to say it equals to r, minus SM, that is the radius of the small circle, that is to say it equals to small r. So in conclusion, OM, the distance between the centers of two circles that have an internal length between them, is capital R minus small r. Okay, so the distance between the centers of two circles that have an internal length between them is the difference between the lengths of their radiuses. In this case, it will be equal, the distance OM equals to capital R minus small r, that is actually the difference between the lengths of those two circles. Okay, so now we will solve the question. We want to find out the radius of the biggest circle that contains those three circles. We will define the center of this circle, that is radius is equal to 4 units, as point A. We will define the center of this circle, that is radius is equal to 9 units, as point B. And we will define the center of the smallest circle, that is radius is equal to 1 unit, as point C. And we will also define the center of the biggest circle as point O, and here we will define the point of tangency of this tangent with this circle as point D. Again, point D is the point of tangency of this tangent with this circle. Then we join points A and D together by a straight line. AD is the radius of this circle. Why? Because it starts from the center of this circle, that is to say from point A, and ends at point D. That is a point on this circle itself, and that is exactly this is exactly the definition of a radius. So AD is the radius of this circle, that is to say it equals to 4 units. And here we will define the point of tangency of this tangent with this circle that is radius is 9 units is point E. Again, point E is the point of tangency of this tangent with this circle. We join points B and D together by a straight line. Here, line segment BE is the radius of this circle. Why? Because it starts from the center of the circle and ends at point E, that is a point on this circle itself. Therefore, BE is the radius of this circle, that is to say, it equals to 9 units. And we will define the point of tangency if of this straight line of this tangent with this small circle is point F. Point F is the point of tangency of this tangent with this small circle. We join point C and F together by a straight line. So here CF is the radius of this smallest circle. Why? Because it starts from the center of the circle, that is to say from point C, and ends at point F, that is a point on this circle itself. Therefore, CF is the radius of this circle, that is to say it equals to 1 unit. So, in the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So I will repeat on rule number 1 again. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So here we have the radius AD. It is drawn to the point of tangency, that is to say it is drawn to point D. That is the point of tangency of this tangent with this circle. Therefore, this tangent will be perpendicular to the radius AD, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, here we have the radius BE. It is drawn to the point of tangency, that is to say it is drawn to point E, that is the point of tangency of this tangent with this circle. Therefore, this tangent DE will be perpendicular to the radius BE, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, here we have the radius CF, it is drawn to the point of tendency, that is to say it is drawn to point F, that is the point of tendency of this tangent with the small circle. Therefore, the tangent DF will be perpendicular to this radius CF, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So here, from point A, we will draw perpendicular to BE. And we will define the touching point between the perpendicular from A to BE as point P. So this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. From point O, we will draw perpendicular to DE. We will define the touching point between the perpendicular from point O to DE as point M. So this angle is equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So here in quadrilateral ADEP, this quadrilateral ADEP, we have three right angles. 1, 2, 3. The sum of three right angles, 90 times 3 is 270 degrees, plus the size of this angle, that is angle DAO, so the total sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We will subtract 90 degrees from this equation and we will get that 360 degrees minus 270 degrees is equal to 90 degrees. So angle DAP is equal to 90 degrees. It is a right angle. Angle DAP, this angle is a right angle, equals to 90 degrees. Therefore, actually, quadrilateral ADEP has four right angles, therefore it is a rectangle, and here, and we know that the opposite sides of a rectangle are equal to each other, so AD equals to PE. AD equals to PE. But AD equals to 4 units. It is the radius of this circle. We can write down that AD equals to 4. AD equals to 4. So from this equation, 4 equals to AD equals to PE. We will derive that PE also equals to 4 units. So we can write here that PE equals to 4 units. Quadrilateral here we will draw perpendicular from point A to OM. So here this is the perpendicular, and we will define the touching point of the perpendicular from point A to OM is point S. So this angle is equal to 90 degrees, and this angle is also equal to 90 degrees. As you can see here, quadrilateral ADMS has 4 right angles. Therefore, it is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, AD equals to SM. AD equals to SM. But AD equals to 4 units. AD equals to 4 units. Because it is the radius of the circle. It is the radius of this circle. From this equation we will derive 4 equals to AD equals to SM, that SM also equals to 4 units. So we can write here that SM equals to 4 units. In the next step, we will join between points A and B by straight line. What is the size of AB? A is the center of this circle that its radius is 4 units. B is the center of this circle that its radius is 9 units. And here, those two circles have an external notch between them. This is the point of tendency between those two circles. And whenever you have an external length between two circles, then the distance between their centers, that is to say AB, will be equal to the sum of the lengths of their radiuses. The radius of this circle is 4 units, the length of the radius of this circle is 9 units. 4 plus 9 is 13. So we can write here that AB equals to 13 units. We also know that BE is the radius of this circle that equals to 9 units. EP equals to 4 units. So what is the value of line segment BP? BP will be equal to BP equals to BE minus PE. I'll repeat again, BP equals to BE minus PE. Okay. Here BP equals to BE minus PE. BE equals to 9 units, PE equals to 4 units, 9 minus 4 is 5. So we found out that BP equals to 5 units. BP equals to 5 units. In the next step, we'll focus on the right triangle, triangle ABP. We'll focus on the right triangle, triangle ABP. Here, in the right triangle, triangle ABP, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle, triangle ABP is AB. The square of the hypotenuse is AB squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BP squared minus AP squared. I repeat again. In the right triangle, triangle ABP, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared equals to BP squared minus AP squared. We have already found out that AB equals to 13 units. So AB squared is 13 squared. 13 squared is 169. 169 equals to BP squared. BP equals to 5 units. So BP squared is 5 squared. 5 squared is 25 plus AP squared. AP is the missing variable, so we will leave it as it is. So, in conclusion, we found out that 169 equals to 25 plus AP squared. Here we will subtract 25 from this equation, and we will get that 169 minus 25 is 144. So 144 equals to AP squared Here we take a root out of this equation, and we will get that AP equals to the square root of 144. The square root of 144 is 12. So AP equals to 12. Here AP equals to 12. AP equals to 12. We know that quadrilateral APDE is a rectangle because it has 4 right angles. Quadrilateral APDE is a rectangle. I will write it down. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AP equals to DE. According to the rule that the opposite sides of a rectangle are equal to each other, AP must be equal to DE. But we have already found out that AP equals to 12 units. So we can write here that AP equals to 12 units. From this equation, we derive 12 equals to AP equals to DE. We derive that DE also equals to 12 units. So we can write here that 9 segment DE is equal to 12 units. Here we will define ME as X. That is to say, ME equals to X according to our definition. Here, quadrilateral SPME has 3 right angles. 1, 2, 3. And according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, angle MSP must be equal to 90 degrees in order to complete the sum of the angles in quadrilateral SPME to 360 degrees. So this angle is a right angle equals to 90 degrees. So quadrilateral SPME has 4 right angles. Therefore, quadrilateral SPME is a rectangle quadrilateral SPME is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, ME is equal to SP, ME equal to SP, but ME equals to X according to our definition. Here, ME equals to X according to our definition. From this equation, X equals to ME equals to SP, we derive that SP also equals to X. SP also equals to X, so we write here that SP equals to X. So here we know that DE equals to 12 units, where ME and ME equals to X. So what is the value of DM? DM equals to DE minus ME. DM equals to DE minus ME. So DM equals to DE, that is 12 units, minus DM, that is X. That is to say, DM equals to 12 minus X. DM equals to 12 minus X. So here, DM equals to 12 minus X. We know that quadrilateral ADMS is a rectangle because it has 4 right angles. Therefore, DM equals to AS. DM equals to AS. So, in quadrilateral ASDM, quadrilateral ASDM is a rectangle. Therefore, DM equals to AS. Repeat again. Quadrilateral ASDM is a rectangle. Therefore, the opposite sides of the rectangle are equal to each other, so DM equals to AS. But we have already found out that DM equals to 12 minus X. So from this equation, 12 minus X equals to DM equals to AS, we derive that AS also equals to 12 minus X. AS equals to 12 minus X. And what is the value of SO? First of all, we will define line segment OM as Y. So OM equals to Y according to our definition. OM equals to Y. So here you can write down that OM equals to OM equals to Y according to our definition. Actually, the point O is here. The point O is here. So OM, it is actually here. So OM equals to Y according to our definition. What is the value of SO? The value of SO, you can see here, SO, line segment SO equals to MO minus SM. I'll repeat again, line segment SO equals to OM minus SM. Again, OM minus SM equals to SO. Again, SO equals to MO minus SM. But MO equals to Y according to our definition. And SM equals to 4. That is to say, SO equals to Y minus 4. Okay? SO equals to Y minus 4. Okay, so we can write here that SO equals to Y minus 4. What is the value of OA? The value of OA, point A is the center of this circle, point O is the center of the biggest circle. And the biggest circle in this circle have an internal lunge at this point. Again, the biggest circle and this circle have an internal lunge between them at this point. This is the point of tangency between those two circles. Therefore, the distance between the centers, that is to say, AO is the difference between the lengths of the radiuses. The length of the radius of the biggest circle will define as capital R, as the length of the radius of the biggest circle. Okay, capital R is the radius of the biggest circle, and we know that the radius of this circle is 4. And the difference between the two radiuses is R minus 4. So we can write down that AO equals to R minus 4. So here, in the right triangle AOS, I will Copy again the right triangle, triangle AOS. So we'll focus on this right triangle, the green right triangle, triangle AOS. We copy triangle AOS here. So in the right triangle, triangle AOS, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO, the square of the hypotenuse is AO square, and it must be equal to OS square plus AS square. I'll write it down, equation number 1. Will be that AO square is R minus 4 square equals to Y minus 4 square, that is OS square, plus AS square, that is 12 minus X square. So here we'll open the brackets of this equation, equation number 1, on both sides of the equation. R minus 4 square is R square plus 16 minus 8R, that equals to Y minus 4 square is Y square plus 16 minus 8Y plus 12 minus X square is 144 plus X square minus 24X. Here we have 16 on both sides of the equation number 1, so 16 will get cancelled. Here we subtract X square and Y square from this equation, and we will add 8R. So we get that R square minus X square minus Y square equals to 8R minus 8Y plus 144 minus 24X. here we'll take a common factor of 8 out of those two expressions, and we will get that r squared minus x squared minus y squared equals to, so we took 8 as a common factor, so here what is left from it r, so we took from it 8 as a common factor, what is left is r, and what is left from minus 8y after we took from it 8 as a common factor. Here what is left from, okay, and what is left from minus 8y after we took from it 8 as a common factor, what is left, it is actually minus y plus 144 minus 24x. So this is the first equation. So here, from point O, we will draw perpendicular to BE. So this angle will be equal to 90 degrees, this angle will be also equal to 90 degrees. We define the touching point between the perpendicular from point O to BE as T. And what is the value? First of all, quadrilateral OSPT has 3 right angles, 1, 2, 3, and therefore the angle SOT must be also equal to 90 degrees. Therefore, quadrilateral SPTO is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, SP equals to here it is, SP is equal to OT. SP is equal to OT in rectangle SOTP. So, but SP equals to X, therefore OT will be also equal to X. What is the value of BT? BT, we know that BE equals to 9 units. And here OM equals to Y, and quadrilateral MOTE is a rectangle because it has 4 right angles, so OM equals to TE. OM equals to TE. So TE, I write it down, OM is equal to TE in quadrilateral OTME. Quadrilateral OTME is a rectangle and the opposite sides of a rectangle are equal to each other, therefore OM equals to TE. But OM equals to Y according to our definition. So can I tell that OM equals to Y? So from this equation, Y equals to OM equals to TE. We will derive that TE also equals to Y. TE equals to Y. Here we can write down that TE equals to Y. TE equals to Y. And BT equals to BE minus TE. BT equals to BE minus TE. I'll repeat again. BT equals to BE minus TE. Here, BT, this line segment BT equals to BE minus TE is equal to BT. Okay, you can see it easily from the drawing that BE minus BT equals to the BE minus TE equals to BT. But BE is the radius of this circle that equals to 9 units. Here. BE is the radius of this circle that equals to 9 units. And T equals to Y according to our definition. So in conclusion, we found out that BT equals to 9 minus Y. 9 minus Y. So we can write here that BT equals to 9 minus Y. And what is the value of OB? O is the center of the biggest circle, and B is the center of this circle that is radius is 9 units. Those two circles have an internal length between them and this point. This is the point of tangency. Therefore, the distance between the centers of those two circles will be equal to the difference between the lengths of their radiuses. That is to say, it will be equal to capital R minus 9. Capital R minus 9. So we'll focus on the right triangle, triangle OBD. I will copy it in a new page. On the right triangle, triangle OBT. We will implement the Pythagoras theorem on the right grand triangle, triangle OBT. So this is the right triangle OBT in the green color. We will implement the Pythagoras theorem on the right triangle OBT. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OB. The square of the hypotenuse is OB squared. OB equals to R minus 9. Therefore, OB squared will be equal to R minus 9 squared. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, it equals to BT squared plus OT squared. BT equals to 9 minus Y. So BT squared will be equal to 9 minus Y squared plus OT squared. OT equals to X, so OT squared will be equal to X squared. So according to equation number 2, we found out that R minus 9 squared equals to 9 minus Y squared plus X squared. Okay? So we join here points O and we join here points C and T by a straight line. But first of all, we will draw perpendicular from point C to BE. And we define the touching point between the perpendicular from point C to BE is point Q. So here this angle equals to 90 degrees and this angle will be also equal to 90 degrees. So here in quadrilateral QECF we have 1, 2, 3 right angles. Any quadrilateral that has 3 right angles, the 4 right angles, the 4 angle must be equal to also to 90 degrees in order to complete the sum of the angles to 360 degrees. So quadrilateral QCEF that has 4 right angles is a rectangle. Quadrilateral QCEF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to QE. CF equals to QE. But CF equals to 1 unit. This is the radius of the smallest circle. From this equation, 1 equals to CF equals to QE. We will derive that QE also equal to 1 unit. QE equals to 1 unit. So here we can write that QE equals to 1 unit. In the Next step, we will join points C and B together by a straight line. We join points C and B together by a straight line. What is the length of CB? Point B is the radius of this circle that is equal to 9 units. C is the radius of the smallest circle that is actually 1 unit. Those two circles have an external launch between them, that is to say they touch each other externally at this point. This point is the point of tangency between those two circles, and whenever you have two circles that have an external launch between them, then the distance between their centers will be equal to the sum of their radiuses. The radius of this circle equals to 9 units. The radius of this circle is equal to 1 unit. And the sum of the radiuses of those two circles is equal to 9 plus 1. That is to say, BC equals to 10. BC equals to 10 units. And what is the value of QB? We know that BE is the radius of this circle that equals to 9 units. QE equals to 1 unit. So BQ equals to BE minus QE. You can see it easily from the drawing. BE minus QE equals to BQ. I write it down. BE minus QE equals to BQ. Again, if BE minus QE equals to BQ. You see it here easily. BE minus QE equals to BQ. So BQ equals to BE is the radius of this circle that equals to 9 units. We have already found out that QE equals to 1 unit. Here QE equals to 1 unit. BQ equals to 9 minus 1 is 8. So we found out that BQ equals to 8 units. BQ equals to 8 units. So here you can write down that BQ equals to 8 units. So we'll focus on the right triangle BQC. On the right triangle BQC, this right triangle BQC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC. The square of the hypotenuse is BC squared, and it equals to the sum of the squares of the perpendiculars. It equals to BQ squared plus QC squared. So we found out that BC squared equals to PQ squared plus QC squared. BC equals to 10. So BC squared is 10 squared is 100 equals to BQ squared. BQ equals to 8, you can see here. So BQ squared is 8 squared, 8 squared is 64, plus QC squared is a missing variable, so we found out that 100 equals to 64 plus QC squared. Here we subtract 64 from this equation, and we will get that 100 minus 64 is 36. So 36 equals to QC squared. Here we take a root out of this equation, and we get that QC equals to the square root of 36 is 6. So we found out that QC equals to 6. You can write here that QC equals to 6 and from point C we will draw perpendicular to OM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. We define the touching point between the perpendicular from C to OM as point U. We will join point C and O together by a straight line. And we will focus on the right triangle, triangle OUC. OUC, the green right triangle. So I will draw this green triangle, triangle OUC in a new page, and we will focus on this right triangle. But here we know that QCFE has three right angles, and the fourth angle must be equal also to 90 degrees, so quadrilateral QCEF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle QCEF are equal to each other. That is to say, QC must be equal to EF. In rectangle QCEF, QC must be equal to EF, but QC equals to 6 units, therefore EF will be also equal to 6 units. So EF also equals to 6 units. And here also we know that quadrilateral MUEQ has here three right angles, 1, 2, and 3. So the fourth angle must be also equal to 90 degrees. So this angle equals to 90 degrees. So quadrilateral UMEQ is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, ME equals to UQ, but ME equals to X, so UQ will be also equal to X. And what is the value of OC? O is the center of the biggest circle, that is to say, its radius is equal to capital R according to our definition. C is the radius of the smallest circle, that is to say, its radius is equal to 1. And those two circles have an internal length between them at this point. Therefore, the distance between their centers, that is to say, the OC, will be equal to the difference between the lengths of their radiuses, that is to say, it equals to R minus 1. So OC equals to R minus 1. And what is the value so here we also know that quadrilateral CFMU is a rectangle because of the fact that it has 4 right angles. So even if it has only 3 right angles, 1, 2, 3, then the fourth angle must be equal to 90 degrees because it must complete the sum of the angles to 360 degrees. So therefore it will have anyway 4 right angles, and any quadrilateral that has 4 right angles is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, CF is equal to UM, but CF equals to 1, so UM will be also equal to 1. UM equals to 1 unit. UM equals to 1 unit. OM equals to Y according to our definition. So here, you know that UM, so this is quadrilateral OUC is a right triangle. What is the value of OU? OU, the value of this side, OU, will be equal to MO minus UM. Again, MO minus UM equals to OU. But, okay, so I write it down here. OU equals to OM minus UM. You can see it easily from the drawing that OU equals to OM minus UM, but OM equals to Y according to our definition, and we already found out that UM equals to 1. So in conclusion, we found out that OU equals to Y minus 1. So here we will implement the Pythagoras theorem on this green line triangle OUC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So according to equation number 3, the hypotenuse is OC, so the square of the hypotenuse is OC squared. It must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to OU squared plus UC squared. So according to equation number 3, OC squared, OC is R minus 1, so OC squared is R minus 1 squared, and it equals to OU squared. OU is Y minus 1, so OU squared is Y minus 1 squared plus UC squared. UC is X plus 6 plus UC, so UC squared is X plus 6 squared. So in conclusion, we found out that according to equation number 3, R minus 1 squared equals to Y minus 1 squared plus X plus 6 squared. So here we have 3 equations with 3 variables, that is X, Y, and R. We will solve out the 3 equations, and we will find out the value of R, that is the radius of the biggest circle, the radius of this biggest circle that we are looking for. First of all, we will open the brackets of this equation, equation number 3, and we will get that R minus 1 squared equals to R squared plus 1 minus 2R equals to Y minus squared, Y minus 1 squared is equal to Y squared plus 1 minus 2Y plus X plus 6 squared equals to X squared plus 36 plus 12x. So here we have 1 on both sides of the equation, so 1 will get cancelled. So here we'll subtract x squared and y squared from this equation, and we'll add 2r to this equation, number 3, and we will get that, according to equation number 3, r squared equals to 2r minus 2y. So actually we have to subtract x squared, okay, minus 2y plus 36 plus 12x plus x squared plus y squared. So here we will subtract x squared and y squared from this equation, equation number 3, and we will get that, according to equation number 3, r squared minus x squared minus y squared equals to, here we have 2r minus 2y, so we will take the common factor of 2 out of those two expressions, and we get it is actually 2 times r minus y plus 36 plus 12x. Okay, so according to equation number 3, we found out that r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. So here we will write down all the 3 equations together, and we will solve, we'll find out the values of x, y, and z. According to equation number 2, we have already found out that r minus 9 squared equals to 9 minus y squared plus x squared. So here we will open the brackets of this equation, equation number 2, and we will get that r squared plus 81 minus 18r equals to 9 minus y squared is 81 plus y squared minus 18y plus x squared. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. Here we will add 18r to this equation and subtract y squared and x squared, and we will get that r squared minus x squared minus y squared equals to 18r minus y. So this is equation number 2. And we have already found out that according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x so here equation number 1 equals to equation number 2. This way it will be equation number 4. Again, equation number 4 states that equation number 1 is equal to equation number 2. That is to say 18 times r minus y is equal to 8 times r minus y plus 144 minus 24x. Here we subtract 8 times r minus y from this equation, and we'll get that according to equation number 4, 8 times r minus y is equal to 144 minus 24x. Here we will divide this equation, equation number 4, by 10, and we will get that according to equation number 4, r minus y is equal to 144 minus 24x over 10. Here we will divide both the numerator and the denominator on this side of equation number 4, on this side of equation number 4 by 2, and we will get that 144 over 2 is 72, minus 24x over 2 is minus 12x, and 10 over 2 is 5. So in conclusion, we found out that r minus y is equal to 72 minus 12x over 5. So here we will compare equation number 2 to equation number 3. In this way we create equation number 5. So 2 times r minus y plus 36 plus 12x equals to 18 times r minus y. Here we'll subtract 2 times r minus y from equation number 5, and we'll get that 36 plus 12x equals to 16 times r minus y. Here we divide this equation by 16, and we will get that according to equation number 5, r minus y is equal to 36 plus 12x over 16. Here we will divide both the numerator and the denominator of this side of equation number 5 by 4, and we will get that r 36 over 4 is 9, 12 over 4 is 3, so it is 3x, 16 over 4 is 4. So, according to equation number 5, we found out that r minus y is equal to 9 plus 3x over 4. And according to equation number 4, we have already found out that r minus y is equal to 72 minus 12x over 5. So here we create equation number 6 that states that r minus y according to equation number 4 must be equal to r minus y according to equation number 5. So this will be equation number 6. So 9 plus 3x over 4 must be equal to 7 minus 12x over 5. Here we will cross multiply equation number 6, and we will get that 5 times 9 plus 3x is equal to 4 times 7 minus 12x. So here we'll open the brackets on both sides of the equation, and we'll get that 5 times 9 is 45 plus 15x equals to 28 minus 48x. So here I will check if there is no mistakes here. According to equation number 3, we have okay. So here we have equation number 2. It states that r minus 9 squared equals to 9 minus y squared plus x squared. Here we open the brackets, r squared plus 81 minus 18r equals to 81 plus y squared minus 18y plus x squared. Here we have 81 will get cancelled, r squared. Question number 4. Question number 1. Square. Here we have 72 minus 12x. So instead of 72, I write down, I wrote down 7. So this was the mistake. So it is 72. So here 9 plus 3 minus x over 4 equals to 72 minus 12x over 5. So here we'll cross multiply equation number 6, and we get that 5 times 9 plus 3x equals to 4 times 72 minus 12x. So here 45 plus 15x equals to 4 times 72 is 288 minus 48x. So here we will subtract 45 from this equation, and we will get that according to equation number 6, (288) minus 45 is 243 equals to 63x. So here we will divide equation number 6 by 9, and we'll get that 243 over 9 is equal to 27. (63x over 9 is 7x, so we found out that x equals to 27 over 7. X equals to 27 over 7. So here we have equation number 5 that states that r minus y equals to 9 plus 3x. So we'll substitute x by 27 over 7, so it is 3 times 27 over 7, all divided by 4. Here, so r minus y is equal to 9 plus 3 times 27 is 81 over 7 over 4. So here we will multiply 9 by 7 and then we will divide it by 7 in order to have a common factor with this expression, and we will get that according to equation number 5, r minus y is equal to 63 plus 81 over 7 over 4. So here 4 will go to the denominator, and we'll get that r minus y is equal to 63 plus 81 is 144, and 4 times 7 is 28. So here we will divide both the numerator and the denominator of this expression by 4, and we will get that according to equation number 5, r minus y is equal to 144 over 4 is 36, and 28 over 7, 28 over 4 is 7. So in conclusion, I found out that r minus y is equal to 36 over 7, and x equals to 27 over 7. So here, according to equation number 2, we have already found out that r squared minus y squared minus x squared equals to 18 times r minus y. So here, according to the algebraic identity, that a plus b times a minus b equals to a squared minus b squared, we get that r squared minus b squared is equals to r plus y times r minus y, and it equals to x squared plus 18 times r minus y. Here we have the value of x and we have the value of y, so we'll substitute x by 27 over 7 and we will substitute r minus y by 36 over 7. We'll do it now, and we will get that r plus y times r minus y is equal to x squared. X is 27 over 7, so x squared will be equal to 27 over 7 squared plus 18 times r minus y, and r minus y is equal to 36 over 7. So we will get here that r plus y times r minus y is equal to 27 times 27 over 7 plus 18 times 36 over 7. Here we will multiply this equation by 7. Here we have 27 over 7 times 7. So here r plus y times r minus y. So here we know that r minus y is equal to 36 over 7. So we will get that r plus y times r minus y, and r minus y is 36 over 7. So it equals to 27 times 27 over 7 times 7 plus 18 times 36 over 7. Here we will multiply this equation by 7, and we will get that according to equation number 2, r plus y is times 36 is equal to 27 times 27 over 7 plus 18 times 36. Here we will divide this equation by 9, and we will get that r plus y is equal to 36 over 9 is 4, and 27 over 9 is 3, so it will have 3 times 27 over 7. 18 over 9 is 2, 2 times 36 is 72. Here we will divide, 3 times 27 is 81, and we will multiply 72 by 7, and then we will divide it by 7 in order to have a common factor with this expression, and we will get that 4 times r plus y is equal to 81 over 7 plus 7 times 72, and 7 times 7 times 72 is 405. So I write it down. According to equation number 2, we found out that 4 times r plus y is equal to 81 plus 504 over 7. 81 plus 504 is 585, so I'll write it down. So according to equation number 2, we found out that 4 times r plus y is equal to 585 over 7. We will divide this equation number 2 by 4, and we'll get that r plus y is equal to 585 over 28. This is according to equation number 2, but according to equation number 5, we have already found out that r minus y, according to equation number 5, we have already found out that r minus y is equal to 9 is equal to 9 plus 3x, not 3, r minus y is equal to 144 over 28, according to equation number 5. So we'll add equation number 2 to equation number 5, and we will get that r plus r is 2r, y plus minus y is 0, so 2r equals to 585 over 28 plus 144 over 28. So 2r is equal to 585 plus 144 is 729 over 28. We will divide this equation by 2, and we'll get that r, the radius of the biggest circle, is equal to 729 over 56 units. I'll write it down. The radius of the biggest circle is equal to 729 over 56 units. That is actually a little bit more than 13 units. A little bit more than 13 units. So the answer to the question is that the radius of the biggest circle is equal to 789 over 56 units. That is a little bit more than 13. That is actually equals to 13.018 units. Okay. Again, the answer to the question is that the radius of the biggest circle is equal to either 729 over 56 units, or in another way we can present it as 13.018 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this big circle. We have here, actually the biggest circle, this circle contains 3 other circles. The radius of this circle is 4 units, the radius of this circle is 9 units, and the radius of the smallest circle is equal to 1 unit. And we want to find out the radius of the biggest circle that contains those 3 circles. Okay? So, in the first step, I will present to you, I presented to you the theorem of external lunge and internal lunge. 2 circles can be tangent to each other in 2 different ways. The first way of tangency between 2 circles is then when they are touching each other externally. As you can see in this drawing, those 2 circles are touching each other externally at point S. Point S is the point of tangency of those 2 circles with each other. And what is the distance between the centers of those 2 circles? We know that the center of the small circle is at point M, and the center of the bigger circle is at point O, or the center of the big circle is at point O. And the distance MO between the centers of those 2 circles is equal to the sum of the lengths of their radii. So here you can see that the distance OM equals to OS plus SM, but OS is the radius of the big circle. Why? Because it starts from the center of the circle and ends at point S. This is the point on this circle itself. Therefore, OS is the radius of this circle, that is to say it equals to capital R. And here we have to add to OS also SM. But what is SM? Line segment SM starts from the center of the small circle, that is to say from point M, and ends at point S, that is the point on this circle itself. Therefore, SM is the radius of the small circle, that is to say it equals to small r. So in conclusion, we found out that MO equals to capital R plus small r. So whenever you have to find out the distance between 2 circles that have an external lunge between them, like in this drawing, the only thing that you have to do is to add the lengths of the radiuses of those 2 circles together, and you will get the distance between the centers of the we will get the distance between their centers. Okay? So here in this specific case, the distance between the centers of those 2 circles equals to capital R plus small r. And we have another type of tangency between 2 circles. The second type of tangency between 2 circles is actually the internal lunge, when 2 circles touching each other internally, like in this drawing. The point of tangency here is at point S, this point, but those 2 circles touching each other internally because the small circle is inside the big circle. Therefore, this kind of tangency is defined as an internal lunge, and here the distance OM between the centers of those 2 circles will be equal to the difference between the lengths of their radii. Okay? And therefore, the distance OM will be equal to capital R minus small r. And as you can see here, why MO equals to capital R minus small r, because SO equals to capital R. Why? It starts from point O and ends at point S. Line segment SO starts from point O, that is the center of the big circle, and ends at point S, that is the point on this circle itself, on the big circle itself. Therefore, SO equals to capital R. And what is the value of SM? SM equals to small r. Why? Because line segment SM starts from the center of the small circle and ends at point S, that is the point on the small circle itself. Therefore, SM is defined as the radius of the small circle. That is to say, OM equals to SO, that is capital R, minus SM, that is small r. In conclusion, we found out that MO equals to capital R minus small r. That is to say, whenever you have an internal length between two circles, that is to say they are touching each other internally, or the point of tangency between the two circles is internally, then the distance between their centers will be equal to the difference between their radiuses. In this case, it will be equal to capital R minus small r. Okay? Then we solved the question. Here we defined the center of this circle as point A. We defined the center of this circle as point B, and we defined the center of the smallest circle as point C. We defined the point of tangency between this tangent and the circle as point D. We defined the point of tangency between this circle and the tangent as point E. And we defined the point of tangency between the smallest circle and the tangent as point F. We joined together points A and D. AD is the radius of this circle, that equals to 4 units. Here BE, we join points B and D together by a straight line. BE equals to 9 units because of the fact that it's the radius of this circle, and here we join points S and F together by a straight line, so SF is the radius of the smallest circle, that is to say it equals to 1 units. Then we define the center of this biggest circle. This circle is point O, and in the next step I presented to you a new rule that is actually rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So here we have the radius AD is drawn to the point of tangency, that is to say it is drawn to point D, that is the point of tangency of this tangent with the circle. Because of the fact that the radius AD is drawn to the point of tangency, therefore the tangent ED will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So actually, this is the implementation of rule number 1 in our drawing. Likewise, we did the same thing here. We have here the radius BE that is drawn to the point of tangency. That is to say, the radius BE is drawn to point E, that is the point of tangency of this tangent with this circle, and because of that fact, this tangent will be perpendicular to the radius BE. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we have the radius CF, it is drawn to the point of tangency, that is to say it is drawn to point F, that is the point of tangency of this tangent with this circle. Therefore, the tangent here will will be perpendicular to this radius CF. That is to say, this angle will be equal to 90 degrees and this angle will be equal to 90 degrees. Okay? Then I draw perpendicular from point A to BE, and unifying the touching point between the perpendicular from point A to BE is point P. So this angle equals 90 degrees and this angle also equals to 90 degrees. Okay? Then triangle ADEP has 3 right angles. Triangle ADEP has 3 right angles, 1, 2, 3. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. Again, quadrilateral ADEP is 3 right angles, and we know that the sum of the angles in any quadrilateral is equal to 360 degrees. That is to say, in quadrilateral ADEP, 270 degrees plus the size of this angle DAP must be equal to 360 degrees. 270 degrees plus the size of angle DAP must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation, and we regard that angle DAP equals to 360 degrees minus 270 degrees, angle DAP equals to 90 degrees. Okay, so this angle equals 90 degrees, therefore, actually quadrilateral APED is a rectangle because of the fact that it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to EP. AD equals to EP according to the rule that the opposite sides of a rectangle are equal to each other, but we know that AD equals to 4 units because it's the radius of this circle. So from this equation, 4 equals to AD equals to AP, we will get that PE also equals to 4 units. Here PE equals to 4 units. And here MS, actually if we focus on quadrilateral MPME, here we actually from point O we draw perpendicular to DE. We define the touching point between the perpendicular from point O to DE is point M. So this angle equals to 90 degrees and this angle equals to 90 degrees. So here in quadrilateral SMEP, we have 1, 2, 3 right angles. Therefore, this angle must be equal to 90 degrees. Therefore, quadrilateral SMEP has 4 right angles. And we know that the opposite sides of the angle of a rectangle are equal to each other. That is to say, PE is equal to MS. In rectangle SPEM, PE equals to AD equals to MS, but AD equals to 4 units, therefore MS will be also equal to 4 units. So we found out that MS or SM also equals to 4 units. And then we actually join points A and B together by a straight line. What is the size of line segment AB? A is the center of this circle, that is radius is 4 units. B is the center of this circle, that is radius is 9 units. Those two circles have an external length between them, and whenever two circles has an external length between them, the distance between their centers is equal to the sum of the lengths of their radiuses. That is to say, AB will be equal to the length of the radius of this circle plus the length of the radius of this circle, that is to say it equals to 4 plus 9, that is to say that it is 13. So AB equals to 13 units. And what is the value of BP? The value of BP will be equal to BE minus EP. Okay, the value of BP will be equal to BE minus PE. So BP equals to BE, that is 9 units, minus EP, that is 4. 9 minus 4 is 5, so BP equals to 5 units. Okay, so AP equals to 13 units, BP equals to 5 units, and the missing variable is AP. So we focus on the right triangle APP. According to the Pythagoras theorem, in the right triangle APP, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BP square plus AP square. AB equals to 13 units. So AB square is 13 square. 13 square is 169 plus BP square. We have already found out that BP equals to 5. So BP square is 5 square. 5 square is 25. Plus AP square is the missing variable. So we found out that 169 plus 25 equals 169 equals to 25 plus AP square. We subtracted 25 from this equation, and we found out that 169 minus 25 is 144. That is to say, 144 equals to AP square. We took a root out of this equation and found out that the square root, we know that the square root of 144 is 12, so AP equals to 12 units. So I can write here that AP equals to 12 units. But because of the fact that quadrilateral APED is a rectangle, why? Because it has 4 right angles. Quadrilateral APED is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, AP equals to DE. AP equals to DE, but we just right now found out that AP equals to 12 units. Therefore, DE will be also equal to 12 units. Then we defined ME as X. DE equals to 12, ME equals to X, so DM will be equal to DE minus ME. That is to say, DM will be equal to 12 minus X. Okay? As I already told you that triangle APD is a rectangle, therefore the opposite sides of a rectangle are equal to each other, so AP equals to DE, but we just right now found out that AP equals to 12 units, so from this equation we derive that DE is also equals to 12 units. Then we know that triangle SPME is a rectangle, and triangle SPME is a rectangle. Triangle SPME is a rectangle because it has 4 right angles, and ME equals to X. So in the rectangle SPME, the opposite sides are equal to each other. That is to say, ME equals to SP. ME equals to SP, but we just right now defined ME as X. So from this equation, X equals to ME equals to SP, we derive that SP also equals to X. And here, actually, quadrilateral ADMS is also a rectangle because it has 4 right angles, and dm equals to 12 minus x. So here in quadrilateral ASMD, ADM equals to AS, but dm equals to 12 minus x, so AS will be also equal to 12 minus x. Okay? And what is the value of AO? A is the center of this circle, that is to say, the center of this circle, A is the center of this circle, and the radius of this circle is equal to 4 units. And here, point O is the center of the biggest circle, that is radius is equal to capital R. And those two, this circle and the biggest circle, has an internal knot between them at this point. This is the point of tangency between those two circles, and therefore the distance between their centers will be equal to the difference between the lengths of their radiuses, and the difference between the lengths of the radiuses is r minus 4. So AO equals to r minus 4. So here we defined OM as Y, and here, so we focused on the green right triangle AOS. In this green right triangle, we know that AO, the hypotenuse, equals to R minus 4, AS equals to 12 minus X. And what is the value of OS? OS equals to OM minus SM. OM equals to Y. SM equals to 4, so OS will be equal to Y minus 4. Okay? So in the right triangle OAS, according to the Pythagoras, so OS equals to Y minus 4, and so I already told you, OS equals to OM minus SM, OM equals to Y, SM equals to 4. So in conclusion, OS equals to Y minus 4. We just right now proved that OA equals to R minus 4 and AS equals to 12 minus X, because the opposite sides of a rectangle are equal to each other, that is to say MD equals to AS and MD equals to 12 minus X, so AS will be also equal to 12 minus X. So in this right triangle OAS, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO, therefore the square of the hypotenuse is AO squared. So AO equals to R minus 4, and AO squared will be equal to R minus 4 squared. It equals to OS squared. OS is Y minus 4, so OS squared will be equal to Y minus 4 squared plus AS squared. AS equals to 12 minus x, so AS squared will be equal to 12 minus x squared. So in conclusion, we got that according to equation number 1, r minus 4 squared equals to y minus 4 squared plus 12 minus x squared. We open the brackets on both sides of equation number 1, and we found out that r minus 4 squared is equal to r squared plus 16 minus 8r. Y minus 4 squared equals to y squared plus 16 minus 8r, and 12 minus x squared equals to 144 plus x squared minus 24x. So here we have 16 on both sides of equation number 1, so x16 will get cancelled. Here we also subtracted x squared and y squared, and then added 8r to this equation, and we found out that r squared minus x squared minus y squared equals to 8r minus 8y plus 144 minus 24x. Here we took 8 as a common factor out of those two expressions. So therefore this expression 8r minus 8y will be equal to 8r minus y. So in conclusion, we got that according to equation number 1, r squared minus x squared minus y squared equals to 8r minus y plus 144 minus 24x. So we finished with equation number 1. Then we focused on the, actually from point O we draw perpendicular to BE, and we define the touching point of the perpendicular from point O to BE as point T. So this angle equals 90 degrees and this angle is equal to 90 degrees. Then here we focused on the right triangle, right green triangle, triangle OBT. What is the value of OB? The value of OB, O is the center of the biggest circle, B is the center of this circle that is radius is 9 units. And those two circles have an internal length between them and this point. And any two circles that have an internal length between them, the distance between their centers, that is to say OB, will be equal to the difference between the lengths of the radiuses and the difference between the lengths of the biggest circle and this circle is equal to r minus 9. So here we know that quadrilateral OTEM is a rectangle. Why? Because it has 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees also. So this is a rectangle. Quadrilateral OTME is a rectangle, and the opposite sides of a rectangle are equal to each other. So ME equals to OT. According to the rule that the opposite sides of a rectangle are equal to each other, ME equals to OT. But ME equals to X. Therefore, OT will be also equals to X. Okay? And what is the value of BT? BT is equals to BE minus TE. Okay? Again, BT equals to BE minus TE. BE is the radius of this circle that is equal to 9 units. TE is equals to OM. And quadrilateral OTEM is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, OM is equals to TE. but OM equals to Y according to our definition. Therefore, OT will be also equal to Y. So OT equals to, okay, so BT equals to BE minus TE, BE equals to 9, TE equals to Y. In conclusion, we found out that BT equals to 9 minus Y, OT equals to X, and BT equals to 9 minus Y, and the hypotenuse OB equals to R minus 9. So here, according to, we focused on the green right triangle OBT. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is OB square. OB equals to R minus 9, so OB square is R minus 9 square. It equals to the sum of the squares of the perpendiculars. It equals to BT square. BT equals to 9 minus Y, so BT square is 9 minus Y square plus OT square. OT equals to X, so OT square will be equal to X square. So in conclusion, we found out that according to equation number 2, R minus 9 square equals to 9 minus Y square plus X square. Okay, so we finished with equation number 2. Then we have equation number 3. Then we actually joint here we know that quadrilateral QC, actually from point C we drew perpendicular to BE. Again, from point C, the center of the smallest circle, we drew perpendicular to BE. So this again equals, and we define the touching point between the perpendicular from point C and BE as point Q. So this again equals to 90 degrees, and this again also equals to 90 degrees. And here, in quadrilateral QCEF, we have 3 right angles, 1, 2, 3. And any quadrilateral that has 3 right angles, actually the fourth angle must be equal also to 90 degrees, because of the fact that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, quadrilateral QCEF is a rectangle. Quadrilateral QCEF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to QE. CF equals to QE according to the rule that the opposite sides of a rectangle are equal to each other. But CF equals to 1 unit because of the fact that this is the radius of the smallest circle. From this equation, 1 equals to CF equals to QE, we will get that QE also equals to 1 unit. So here QE equals to 1 unit. And what is the value of, so here we actually focused on we join together points C and B by a straight line. So what is the value of CB? The value of CB, B is the center of this circle that is radius is equal to 9 units, and C is the center of the smallest circle that is radius is 1 unit. And those two circles have an external length between them, therefore the distance between their centers, that is to say BC, will be equal to the sum of the lengths of their radiuses, that is to say it will be equal to 9 plus 1, that is to say BC equals to 10 units. And what is the value of BE? BE actually equals to 9 units, and QE equals to 1 unit. Therefore, the value of BQ the value of BQ equals to BE minus QE. Okay, BQ, here BQ equals to BE minus QE. BE equals to 9 units, QE equals to 1 unit. So BQ equals to 9 minus 1 is 8. So we found out that BQ equals to 8 units. So in triangle BQC, the right triangle BQC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, so the square of the hypotenuse is BC square. BC square equals to BQ square plus QC square. BQ square plus QC square. BC equals to 10 units. BC square is 10 square, 10 square is 100, equals to BQ square. BQ equals to 8 units. So BQ square is 8 square. 8 square is 64. Plus QC square is the missing variable. So 100 equals to 64 plus QC square. We subtracted 60 degrees from this equation, and we got that 100 minus 64 is 36. We subtracted 64, so 100 minus 64 equals to 36, so 36 equals to QC square. We took a root out of this equation, and we found out that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units. Here, QC equals to 6 units. But because of the fact that QCEF, it has 1, 2, 3 right angles, therefore the fourth angle must be equal also to 90 degrees, therefore quadrilateral QECF is a rectangle, and the opposite sides of a rectangle are equal to each other, and the opposite sides of the rectangle are equal to each other, so QC equals to EF, but QC equals to 6 units, therefore EF must be also equal to 6 units. Likewise here, we know that quadrilateral EMEQ is a rectangle, therefore ME equals to EQ, but ME equals to X, so here EQ will be also equal to X. Actually here, before that, actually we from point C we drew perpendicular to this point, and so this angle equals to 90 degrees and this angle equals to 90 degrees. We defined the touching point between the perpendicular from point C to OM as point U. So actually UQME is a rectangle because it has 1, 2, 3 right angles. The fourth angle must be equal also to 90 degrees. That is to say ME equals to EQ, but ME equals to X, so EQ will be also equal to X. So in conclusion, we found out that UC is equal to X plus 6, and what is the value of OU? Here OU equals to OM minus UM. OU equals to OM minus UM. OM equals to Y according to our definition. MO, actually here, UM, we know that MECF is a rectangle and the opposite sides of the rectangle are equal to each other. That is to say CF is equal to UM, but CF equals to 1, so UM will be also equal to 1. So UM equals to 1. So in conclusion, we found out that OU equals to 1 minus 1. So here OU equals to 1 minus 1, and UC equals to x plus 6. And what is the value of OC? O is the radius of the biggest circle. That is to say, is the radius, O is the center of the biggest circle. That is to say, is the center of the biggest circle that is radius is capital R. C is the center of the smallest circle that is radius is 1. And the biggest circle and the smallest circle has an internal notch at this point. Therefore, the distance between their centers, that is to say OC, will be equal to the difference between the lengths of the radiuses, that is to say it will be equal to R minus 1. So here OC equals to R minus 1. So we focused on the right triangle OUC. We have already found out that OU equals to 1 minus OU equals to y minus 1, UC equals to x plus 6, and OC equals to R minus 1. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square, that is the square of the hypotenuse, must be equal to UO square plus UC square. OC square equals to UO square plus UC square. OC equals to R minus 1, so OC square equals to R minus 1 square. OU square equals to y minus 1, so OU square equals to y minus 1 square. UC equals to x plus 6, so x plus 6, so UC square equals to x plus 6 square. So here we open the brackets on both sides of equation number 3, and we got that R minus 1 square equals to R square plus x square minus 2R, and it equals to y minus 1 square. Y minus 1 square equals to y square plus 1 minus 2y plus x plus 6 square is equals to x square plus 36 plus 12x. So here we have 1 on both sides of the equation, so 1 will get cancelled, and then we add 2r to this equation, and we got that r square equals to 2r minus 2y plus 36 plus 12x plus x square plus y square. We subtract x square and y square from this equation, equation number 3, and we found out that r square, according to equation number 3, r square minus x square minus y square. Here we took 2 as a common factor from 2r minus 2y, and we got the expression of 2 times r minus y plus 36 plus 12x. According to equation number 4, r minus y square equals to y 9 minus y square plus x square. We open the brackets here, and we got that r square minus x square minus y square equals to 12 times r minus y. This is equation number 2. And equation number 1, we have already found out that in equation number 1, r square minus x square minus y square equals to 8 times r minus y plus 144 minus 24x. So here we created equation number 4 that states that r square minus x square minus y square, according to equation number 1, must be equal to r square minus x square minus y square, according to equation number 2. This is equation number 4, that's 18 times r minus y equals to 8 times r minus y plus 144 minus 24x. So here we subtracted 8 times r minus y from this equation, equation number 4, and we got that 8 times r minus y equals to 144 minus 24x. Then we created equation number 5, and Actually here we divided the equation number 4 by 10 and we got that r minus y equals to 144 minus 24x over 10. Here we divided both the numerator and the denominator by 2. So 144 over 2 is 72, minus 24x over 2 is minus 12x, and 10 over 2 is 5. So in conclusion we got that r minus y equals to 72 minus 12x over 5. So according to equation number 4, r minus y is equal to 72 minus 12x over 5. Then we created equation number 5, that states that r squared minus x squared minus y squared according to equation number 2 must be equal to r squared minus x squared minus y squared according to equation number 3. So we got this equation number 5 that states that 2 times r minus y plus 36 plus 12x equals to 18 minus r minus y. We open the brackets here. Here we got that 36. Actually here we subtracted 2 times r minus y from this equation number 5, and we got that 36 plus 12x equals to 16 times r minus y. We divided equation number 5 by 16, and we got that r minus y equals to 36 plus 12x over 16. Here we divided both the numerator and the denominator by 4, and we got that 36 over 4 is 9, and 12 over 4 is 3, 12x over 4 is 3x, 16 over 4 is 4. So in conclusion we got that according to equation number 5, r minus y equals to 9 plus 3x over 4. Then, so we have equation number 5 that says that r minus y equals to 9 plus 3x over 4, but according to equation number 4, we already found out that r minus y equals to 72 minus 12x over 5. Then we created equation number 6 that states that r minus y according to equation number 5 must be equal to r minus y according to equation number 4. So this is equation number 6 that states that 9 plus 3x over 4, that is r minus y according to equation number 5 must be equal to r minus y according to equation number 4, that is 72 minus 12x over 5. This cross multiplied the equation number 4, and we got that 5 times 9 plus 3x equals to 4 times 72 minus 12x. We open the brackets on both sides of equation number 6, and we got that 5 times 9 is 45, 5 times 3x is 15x, 200 times 72 is 288, 4 times 72 is 288, 4 times minus 12x is minus 48x. So here we have 288 minus 45 is 243, that equals to 15x plus 84x is 63x. Here we divided this equation by 9, and we got that 243 over 9 is 72, and 63x over 9 is 7x. We divided this equation by 7, and we got that x equals to 27 over 7. So here we can put the value of x inside equation number 5. We did it, and we got that 9 plus 3, and we substituted x by 27 over 7. And we got that 9 plus 27 over 7 over 4 equals to r minus y. Here 7 times 3 times 27 is 81, so it is 81 over 7. Then we multiplied 9 by 7, and then we divided by 7 in order to have a common factor with this expression, and we found out that r minus y equals to 63 plus 81 over 7 over divided by 4. So r minus y equals to 144 over 28 because of the fact that 7 times 4 is 28. Then we have equation number 5 that states that r minus y equals to 36 over 7, and we have already found out that x equals to 27 over 7. Then we have equation number 2 that states that r squared minus y squared minus x squared equals to 18 times r minus y. So here, according to the algebraic identity, that a plus b times a squared minus b squared equals to a plus b, a squared minus b squared equals to a plus b times a minus b, we will get that r squared minus y squared equals to r plus y times r minus y, and it equals to x squared plus 12 r minus y. So r squared plus r plus y times r minus y equals to x squared. X equals to 27 over 7. So x squared is 27 over 7 squared plus 18 times r minus y. And we've already found out that r minus y equals to 36 over 7. So 18 times r minus y is 18 times 36 over 7. We substituted r minus y by 36 over 7. And we got here that r plus y times r minus y equals to 27 times 27 over 7 times 7 plus 18 times 36 over 7. So here we substituted r minus y by 36 over 7, and we got that r plus y times 36 over 7 equals to 27 times 7 over 7 times 7 plus 18 times 36 over 7. We multiply this equation number 2 by 7, and we got that r plus y times 36 equals to 27 times 27 over 7, and here the 7 will be cancelled, and we left only with 18 times 36. Then we divided this equation number 2 by 9, and we got that 36 over 9 is 4, so here we have, according to equation number 2, 4 times r plus y equals to 27 over 9 is 3, so here we have 3 times 27 over 7 plus 18 over 9 is 2, so 2 times 36 is 72. So in conclusion, we got that 4 times r plus y equals to 3 times 27 is 81, so over 7. Then we multiplied 72 by 7, and we divided by 7 in order to have a common factor with this expression. So we got this expression that 81 plus 7 times 72 over 7 equals to 4 times r plus y. So we divided this equation number 2 by 2, and we got that 4 times r plus y equals to 81 plus 72 times 7 is 504 divided by 7. So 4 times r plus y equals to 81 plus 504 is 585 over 7. So we got that r plus y, we divided this equation by 4, and we got that r plus y equals to 585 over 28 because of the fact that 4 times 7 is 28. So we got that r minus y, according to equation number 5, equals to 144 over 28. And r plus y equals to 585 over 28. So we added equation number 2 to equation number 5. And we got that r plus y is 2r and y minus y is 0. So 2r equals to 585 over 28 plus 144 over 28. So here 585 plus 144 is 729. So we got that 2r equals to 729 over 28. we divided this equation by 2 and we got that r equals to 729 over 56 units. So we found out that the radius of the biggest circle is equal to 789 over 56 units, or in other way we can represent it as 13.018 units. Okay, again the answer to the question is that the radius of the biggest circle equals to either 729 over 56 units, or in terms of numbers it equals to 13.018 units. Okay, thank you very much.